Hello, I'm Daren Fulwell, IP Fabric Product Evangelist, and I'm going to talk through with you how we position our product as a key part of the automated network operations ecosystem. We'll take a look at some examples of how the data in the product is exposed through our open API in order to ensure that the network engineers can get answers to the more complex questions that they might have, and that the rest of the IT team are working with up-to-date network inventory, configuration and state data. It's been fascinating over recent times watching how the perception of the network engineer has changed. In the red corner, programs like Cisco's DevNet and Juniper's NRE labs have gone a long way to educating network engineers to become more au fait with software engineering concepts in a bid to prepare them for their jobs to be automated away. Then in the blue corner, you have the traditionalists who insist that there will always be a job for network engineers because the more overlays we introduce, the more we increase complexity rather than decrease it. And the more complexity there is, the more we need real network engineers to fix things when they break, because there are more abstractions to manage. I'm sure everyone will agree there's more than a grain of truth in both viewpoints. Templating and automation may reduce numbers of pure routing and switching specialists, but the industry simply continues to evolve, bringing new challenges in new areas for the network engineer. It's not until recently that the relatively new disciplines of SD-WAN and cloud networking appeared, for example, and it will remain vital that engineering teams adapt to grasp those technologies and any others that may follow in order to automate, integrate and orchestrate. Network engineers are not going to disappear or turn into software developers. Instead, they'll operate the tools that the developers create for them to do the automated tasks. And importantly, we believe they'll be required to become something more akin to data scientists, using tools like Python to extract and manipulate data from the variety of networks and technologies that they look after. The better their skills and the higher quality of the data they have, the better the insights they have into the state of the network, better ensuring in turn that it provides the right capabilities to meet the business intent and maximising service availability. After all, that is what the business pays for. IP Fabric helps us down that path. We harvest these huge amounts of data from the network, analyse it and model it so that the software developer or network engineer doesn't have to assemble the tooling or write the scripts to do that themselves. In this alone, we take care of what one of our customers estimates to be 95% of the effort of today's network automation projects. He refers to it as the toil, the grunt work of low value, which needs to be completed in order to realise the full benefits of automation, which typically come from that remaining 5% high value effort. Consider then that IP Fabric reduces the time to realise value for network automation projects. You're starting from a point where you already have the data you need and you can build from there. And because we don't stop at one vendor or technology or network domain, if you think of a new innovative network automation project, the chances are that we've already collected the data that you need to make it happen. So let's start with how we can extract useful insight from the platform programmatically. We receive reports from the service desk that users are struggling to access a system from site 45 that you can see here in front of us. The system being having an IP address of 10.67.102.7. They've done end-to-end path checks and there are no immediate obvious issues. So we log in to the platform. We make sure that we're looking at today's data and we go and zoom in on the egress point from that site into the wider network. This router down here, L45 EXR1, and focus on the routing at that active exit point. What we want to do is have a look and see just what the routes look like in order to get to that destination. And we don't want to search for a string, we want to search the routing table and do a prefix match in effect. As you can see, we have a 10/8 summary route that covers that destination. So that should be okay. But we know that the platform was working yesterday, and we're just wondering, well, has anything changed? Let's turn detective and look to see if we can track down what's going on. Now, as with any table in the platform, we're able to export the data from the table you see in front of you through CSV files by clicking the button here, or more interestingly, if we click on the question mark, we're able to get information that allows us to access that same data through the IP Fabric API. We have a quick description of the table at the top. I'll come back to this section in a second, but the API documentation down the bottom here shows us the API endpoint URL and the method that we need to use to access it. And there's a whole load of description in here about the payload. The payload lists out the format that we're expecting to get results in. We're also showing the filters that we've got applied to the data in order for us to extract that information. So what I'm going to do, I'm going to copy this payload from here. I'm now going to open up Postman, and we're going to pop that payload into Postman and run that request. And as you can see, we get a response very quickly. No pausing of the video there. And as I scroll it down, we can see that we have the snapshot matches the latest snapshot that we saw in the UI, that we've got a count of one entry, and that one entry is that 10/8 route we saw before. Now, that's great, but if we submit that every time, we'll just get the same result from the same snapshot. If I were to replace the snapshot ID in the query with a $last keyword, what that will do is use the latest snapshot that's loaded in the system. Hit send. I'll actually get the same result because, of course, I'm using the latest snapshot in the UI, and yeah, we can see there the snapshot ID matches. But we have another keyword that we can play with, which is prev, P-R-E-V, referring to previous. And if I hit send there, what that's doing is pulling not the latest snapshot, but the snapshot before. Again, scroll to the bottom, you can see it's a different snapshot, and this time our count has gone up to 2. So what's happened? Well, we have an alternative route, and it's a more specific one, so it's going to be chosen over the 10/8 summary for 1067.102.0/24. So something's definitely changed. We've got a different route here when the platform was working from yesterday, and then we've got the summary route from when the platform wasn't working today. Now, this is starting to get interesting. I'm starting to wonder now if there's more information that I need to be able to pull from the routing table of this device in order to get to the bottom of what's going on. What I'm going to do, I'm going to resort to using a Python script. What we have here is a prepared one with some functions in it to fetch the route data from IP Fabric. We've got a conversion function here to convert that into a list, and then a diff function to compare two lists. And what I'm going to do, I'm going to fetch the route entries from the IPF server, in particular filtered for the host, the L45EXR1, and I'm going to use the last snapshot. We'll capture those as the new routes. We'll capture the old routes from the previous snapshot, and then we'll diff those two sets of routes and print the results out. So rather than step through that, what we'll do is we'll just run the script. As you can see, 1174 entries from today's snapshot, 1153 entries from yesterday's snapshot, so clearly a difference between the two. Now this set of routes here are the ones that have been added from between yesterday and today, and then if I hit enter, we have the list of routes that was deleted between the two. And of course we can see a 1067.102 route was present yesterday, and not today. Now, that's not going to get us to the bottom of the problem, but it does give us a bit more insight into what is going on around the routing table of that environment. And as you can see, that's taken just a little bit of coding knowledge and some understanding of the data in order to get to that point. Now, I am no programmer or developer. I'm a network engineer, like most of the people who will be watching this video. But the Python code that you've seen in operation there is mine. I wrote the functions that pulled that data out of IP Fabric and manipulated it to give us the answers we were looking for. I got the answers I wanted because I understood the meaning of the data that IP Fabric was presenting to me and how to use it. So you can see, I'm now a network data scientist, and IP Fabric is my ultimate reference source of network data. Another aspect of our open API is the ability to integrate IP Fabric with the management and monitoring processes and ecosystem to improve the quality of visibility for IT teams. The idea is not to just automate network devices, but to enable automation of network operations by building pathways for network data between tools, opening up access to network information and insights. We're working closely with our customers and partners on creating a development community around the product. Over recent months, we've seen exchanges of information, code and announcements for open source projects to provide access into the data in IP Fabric from Nornir, Ansible and Netbox, amongst others. We take a very active role in exploring those automation stories and building new features into the platform from requests raised by the community members for specific automation use cases. Examples include the recent addition of API tokens and webhooks to the platform, which have enabled us to be able to build integrations with, amongst other things, chat systems. In this current version, webhooks can be sent out from the platform on network discovery events and on calculation of intent verification rules. With a webhook handler, these events can then be relayed onwards, and in this case, we show them in a Slack channel. So as we can see here from this inventory table for interfaces, we have an intent verification rule created for basically to color the duplex column here based on the state of the device's duplex settings. So if we click through on this, what we can see is we color that field green if the link is up at layer 2 and the duplex contains the word full. Now we put contains the word full because depending on the platform, some platforms may report full duplex, others may just report full, some may use different capitalization and so on. So our contains operator here enables us to account for all of those different options. We color the field blue if we have the layer 2 state equals up, but we're not able to determine what the duplex is. And so the field is empty. Now that may be because the platform simply doesn't report it properly, or it may be that it's a sub interface or a VLAN interface or similar. What we want to do is we want to add a red state to that for the layer 2 being up, but the duplex being defined but not full. And what we'll do then is we'll just add that rule in here very quickly. We'll state that the duplex is not empty, so it is defined. And we will say that it doesn't contain the word full, for the same reasons as the green does contain full. Now, if we update that rule, we can see that the report is saved. The interface duplex now has a red box next to it with a number in it, and we've had a notification from Slack. If we go into Slack, we can see what's happened here is that when that intent verification rule has been recalculated, It's sent a webhook to our webhook handler, which has then retrieved the information back from IP Fabric and passed it on into the Slack channel. As we can see, the intent verification process was triggered, completed, and then here's the data that's associated. And if we just move that to one side, you can see the numbers match up. 1202 a green, 2689 a blue, and 197 a red. What that enables us to do then is as a snapshot is run overnight, the intent verifications for that snapshot are all run at the same time. We can capture that information and pass that through into Slack, effectively doing a morning check type process and providing a notification capability from the platform directly. And of course, if we've got integration of that type into Slack, there's nothing stopping us creating further integrations. For example, we can build a Slack app to add additional commands into Slack, such as the /IPF here, in order to retrieve, let's say, inventory data into the platform. Let's give you an example. Imagine that I'm a network management engineer. I'm responsible for maintaining the network monitoring and management platforms. I don't need access necessarily to the full platform for IP Fabric, but it'd be good to see what's in there, what information's there, what information I can get out, and just get a read-only view of what's going on. What we can do is we can integrate the IP Fabric into my Slack channel so that I'm able to carry out those sorts of queries. And let's say, for example, last night I know that the network team brought up a new site into the network. L81 was connected up to the network and started operating. I want to see if IP Fabric knows anything about that site. So I can just run that inventory command and run it with a filter to say, tell me about site 81. And there we go. IP Fabric has been queried by our handler that sits in between Slack and the IP Fabric system, has fetched the information back and then passed it through into the Slack channel. As you can see, 9 devices listed there that have been discovered overnight. Fantastic. But I wonder when the network team actually introduced those into the network and IP Fabrics picked them up, did they update PRTG for monitoring? Well, let's have a look. Right, no, they didn't. There's nothing in the PRTG dashboard here to show any devices that have come up from that site 81. So how do we fix that? Well, it's pretty straightforward. What we'll do is we'll fire up another Python script, and that Python script can be used to fetch the IP Fabric inventory information from the latest snapshot, filter it based on which site that we input, and then we can cycle through that list, pushing the data that we need to into the PRTG API to first create the device, then tag it with some useful information we want to put in there, and then to kick off the auto discovery. So let's run that script. And we want to run that for site L81. You can see there it's pulled back the list of sites from IP Fabric that are in that site 81, and of course they match the ones that from the Slack channel, which you'd hope they would. And we want to import all of those. So now that's looping through, taking the information from each one of those and pushing that through the API into PRTG in order to create it. So if I flip back to PRTG, nothing's happening. Okay, yes it is. There we go. So slowly that information starts to appear. If I click through on one of the devices to the settings, you can see there that it's tagged as we'd hoped, and just going back to that discovery, activity. You can see here the background task, 9 auto discoveries are running. Phew. You can see from the Python script, it made me think of a basic program that I used to write back in the day. That knowledge from 30 or 40 years, who knew that would come in useful again? All those print statements and input statements. Anyway, I hope that you've managed to get a flavour from our demos of the power of the IP Fabric platform. Not only do we have this unrivaled interactive in-depth analytics tool for the entire network, but we also empower the network engineer to become a network data scientist through access to that deep, rich data. And we can integrate with the wider operational ecosystem to provide access to that pool of data to whoever and whatever needs it to enrich the operational processes.